This is Mr. Anderson for Kellogg Community College, and we are going to be today in Chapter 5, the second part of our test review for Unit Test 2. And we're going to be doing the second page of the unit review and is specifically talking about the binomial probability formula and all the fun things we can do with that. Now, I'm going to give you the formula, though I should say that you will be given a formula sheet, so you will not have to memorize this. However, you will have to know where all of these things come from, because the formula sheet does just that. It tells you what the formula is, but it does not tell you what all of these things mean. So this is n factorial divided by n minus x factorial times x factorial times the probability of x multiplied by the probability of q raised to the n minus x power. Now, that formula will be given to you. I'll do a little cursive q here, but they will not tell you what each of these letters mean. What these letters stand for is n is going to be the size of your sample, the number of people or the number of trials you are working with. X is your target value. This is what you're going to consider to be your goal of seeing. And let me just kind of maybe put this in context here. Let's say you were surveying, you wanted to get 100 people, and you wanted to see, like, what are the chances that 50 out of those 100 people would fit this demographic, whether they'd be female or vote a certain way, either Democrat or Republican. So your size would be how many people you're going to look at, and then the target value is what you're hoping is going to happen. And they're going to give you the P, which is the percentage of the success. So this is going to be in a percent or decimal form, and Q is the complement of that, or this is the failure to get your percentage. So let's just say that 50% of the population is female. So let's say if you gave a random problem and said, okay, what are your chances of getting out of 100 people 75 women, at random? So your n would be 100. The target value is 75, so this would be 25 factorial times 75 factorial. The probability of success is 50%, and that would be of your 75. You're 75 right there, because that's what we were looking for. And then this would be the failure, which is 25. So doing this formula for that story problem, hypothetically, I just made up, would make sense. So we're going to start off with just a problem that just tests your ability to plug things in and get the answer. So this would be 5 factorial divided by, in this case, 3. So we're going to have x is equal to 3, so this is going to be 5 minus 3 factorial, or 2 factorial. I'm going to use parentheses instead of multiplication, since things might get a little messy with p and q up here. And then what we'll have is 3 factorial, again with or without parentheses is a style choice. And then we're going to multiply by p, and that's going to be 0.63 raised to the third power, because you see this is the x, the same x as we have down here. And then we have and since I want to kind of use parentheses to kind of keep the style going, the q is going to be, because notice this didn't give a q, but you should know q from the complement of p, and so this is going to give me 2. You would type that into your calculator and get an answer of 0.342, or 34.2%. And I will right now show you how that looks on a calculator, but I want to, before I kind of take this away, is look at the beautiful symmetry of this equation. I love it because I see these numbers 2332 as kind of a mathematical palindrome. A palindrome is a word that's spelled forward and backwards the same, like the word race car. Notice it's spelled forward and backward the same way, and yes, Bob is a palindrome as well. But this is kind of a mathematical palindrome. Look at that, 2332. These two add up to 100%. The 5 and the 2 and the 3 add up to 5. It's the 2 and the 3 add up to 5. This pattern, even though the formula will be given to you, if you know what these 4 things are, it's pretty straightforward. So what I want to do is show you this on the technology. I'm going to get rid of this right now. So, write this down before this goes away. And what I have here is a little technology. Let's bring this up here. All right, shrink it just a bit. Okay, so I can actually, let's see here. emulation options 2 times view. Okay, this is good enough. So what we'll have here is we'll type in the 5 factorial. So click the math key and take it over to probability and use option 4. And then we're going to divide. Now this is incredibly important because the 2 factorial and the 3 factorial have to be inside the same parenthesis for the calculator to think that it is part of that denominator. So if you don't actually have the 2 factorial and the 3 factorial in the same place under that denominator, it's not going to compute it right. I've had people put separate parentheses around this, and I know I did on paper, but technology-wise, you have to do this. This is the numerator, this is the denominator. Then you can multiply that by the 0.63 raised to the 3rd power, and then multiply that, or use parentheses, the 0.37 raised to the 2nd power. And this gives you that 34.2%. I will go ahead and do these for you, and especially I'll show you a little shortcut once we get through with this here. It's kind of nice. So I'm going to just kind of push the calculator down and get this next problem right here. All right, so 40% believe, now this problem here, this problem number 5 is going to be for parts A, B, and C. And C I know is right here at the bottom of the screen, so what I'm going to do is probably keep all of this on the same page, but I would like to have you highlight this or write this down on a separate piece of paper if you don't have the worksheet in front of you, because I'm going to move this and obscure this. 40% believe that a college education is not needed for success in business. Now we're going to choose 5 students at random and see what is the probability that 2 people agree with this statement. Okay, that looks like it's the best way to fit this here. Okay, so to the problem. Now what we have here is we're going to choose 5 students at random for each of these problems. So my n is going to be equal to 5. In this case, my x is going to be 2 because I'm looking for the probability that 2 people agree with this statement. So what are the chances that 2 out of 5 people, if the percentage is 40%, are going to say that you don't need a college degree for a business? The probability of getting people to say this is 40%, and therefore the Q is going to be the complement of that, which is 60%. So my probability of getting 2 out of 5 people to say that this is true is going to be the following factorial equation. 5 factorial divided by, and I'll use the single parenthesis here, 3 factorial, 2 factorial, so this mimics what we're going to type on our calculator, times 0.40. You see, this is why it looks weird, right? 0.40 to the, or 4 tenths or 40%, to the 2nd power times 0.60 raised to the 3rd power. Now, if I do that correctly, I get an answer of, it's a little bit different than the last equation, so you can't just copy the answer, is 34.6%. And this is going to be the answer to that problem, 34.6%. Now, the probability that at least 2 agree with this, and it probably should say that this is going to be, this at least piece means that we're going to have multiple equations for this. So we're going to have the probability that 2 people agreed with this, the probability that 3 people agreed with this, the probability that 4 people agreed with this, and the probability that 5 people agreed with this. If I add all of those up, I am going to get the total number, or the total percent, that at least 2 people agree with this statement, because I'm getting the probability that 2 people agree, 3 people agree, 4 people agree, and 5 people agree. Now, what that means is I have to do 4 problems. And I will tell you the answers, and I would suggest that you write these answers down, because I want to show you them on the calculator and then get to the final answer, which will match what I have written here. So what we have is the 0.346, or the 34.6%, from this problem here. Now what I'm going to do is do the problem 3 more times, or a total of 4 times, so I can get these answers, 23.0%, which gets rounded, and then the 0.077 or 7.7%, and the probability that all 5 people think that you don't need a business degree is only 1%, or 1.0%. And when I add all these up, I get an answer of 66.3%. But let's actually go through the calculator and show you how to do this problem the most efficiently. Now, I didn't show you on the calculator how to do problem 2 part A, or sorry, problem 5 part A. So let's actually go and do that now. All right, so if I'm going to go back up and do problem 5 part A, don't know why I keep saying 2. All right, bring my calc up here. Now you'll notice that I actually have this from problem number 4. If I click the second button and the enter button, the entire equation comes back, which is why I don't allow you to share calculators on the test, because you could easily just pass either your answers or the previous work to your neighbor. But using the arrow keys, you can kind of back this up and change the problem to whatever you need it to be. In this case, the denominator was 3 and 2 instead of 2 and 3. And then we would move over to the point 40. I'm going to change that, 63% to a point 40, and that would be a 2. And change this to a 60 and change that to a 3. Sure beats typing this all in again, right? Going all to the probability menu. Well, this is where I get my 34.6%. So remember, I got to do this now 3 more times. So let's go hit second enter. And I just have to go back and change this to a 2 and a 3, because this is for the 3 people agreeing. And so that changes this to a 3 and changes this to a 2. And that's how I get my 23.0% chance. And now we're going to hit second enter again and go to the 4 people agree with this statement. And the 4 people agreeing with this statement is going to be 1 and 4. And changing that to a 4 in the power, and then changing this to a 1 in the power here. So that's 7.6%, or 7.7%, like I said. And finally, we have to do 5 out of 5, so that's going to be 0 factorial and 5 factorial. And let's move this over here. This is going to be a 5, and this is going to be a 0. And that gives me my 1%. So if I added up those 4 numbers, and you would write each of these numbers down as you type them into your calculator, that would give you the answer for this problem, which was 66.3%. Please understand that you better show some work about what you're typing into your calculator, because if you make a mistake in typing any of these in and not show your work, I can't give you partial credit. So it's good to write all this down here. And yes, there is a combination shortcut, but I feel that knowing all these steps of NXPQ, this will get you to the answer with the fewest amount of calculations. And now what we're going to do is the probability that fewer than 3 people will agree. Well, I'm going to freeze the calculator and write down what I'm going to do here, because if I want the fewer than 3 people agree, that would mean that my n again is still 5. My x in this case is going to be 0, 1, and 2. That's fewer than 3 people agree. And then we have our p is 0.40. That never changes in this problem, and the q is going to be 0.60, because that is one of the stipulations of the binomial probability formula, is that your percentages are not going to change between problems. So the probability that fewer than 3 people agree, so what we have to do is do a p of 0 plus a p of 1 plus a p of 2. Now the probability that 0 people agree is also going to be, if I do this out, I'm going to do all of this out on the calculator, but this is going to be, just tell you the answer, is going to be about 7.8%. This is going to be about 25.9%, and this is going to be 34.6%, or sorry, the decimal, it should be right over here, since I'm using decimals here and not percentages. Let's see if I make that 6 big enough so you don't see that anymore. Perfect, no one knows the difference. Because this A right here, the 2 agree with us, that's just used down here. But if you add all 3 of these numbers up, you get an answer of 68.3%. Now let's use the technology to kind of get us these 3 numbers and show you this last time how to use the technology to best rock out the probabilities here. So what we want now is, let's clear this out, second enter, we'll get to the equation back. We want the probability that no one agrees with this statement. All right, and that's going to be 0, and that's going to be 5. And so the answer there is 7.8%, which is what we had written down. Second enter, probability that 1 person agrees with us, so that's 4 and 1. and then take that to 1 and take that to 4. Boop. And that's 25.9% rounded correctly. And finally, we're going to go to 2 people. And yes, we've done this before, but to show you the flow of the problem, 3, 2, 2, 3, enter. Bam, 34.6%. Now, if we add those 3 decimals together, the 0.078 plus the 259 thousandths, or 25.9%, plus the 304.346, and we get an answer of 68.3%, 683 thousandths. Yeah, I want that as a percent, so that would be helpful. All right, back to work here. Let's put this away and get back to the screen. Okay, so to find the mean, what we have to know is we have to know our n and our p, and that's going to be given to us in the problem. And the standard deviation is going to be the square root of the n times p times q. Now, because the p is going to be given to us, the q is going to be the complement of p, so you just subtract that from 100%. Now, you'll note that the problem asks for the variance as well. Notice that I've given you these 2 formulas. The variance formula is just the standard deviation before you take the square root. So it's just n times p times q. And all of these formulas are on your formula sheet. It's just, again, good to know where these letters and numbers come from. So what we're looking at is if 5% of the original PlayStation 3 is code effective, find the average number that'll break the variance in the standard deviation of 1,000 systems. What's interesting is that a success is a broken machine. So we have to keep that in mind as we do the mean. The mean is going to be n times p, and the n is going to be our 1,000 systems, and our p is going to be that 0.05. And that 1,000 times 0.05 is 50 machines. 50 systems are going to be basically defective. That's the average. But, you know, we need the standard deviation to know, like, roughly what's the normal amount, give or take, you know, 34% chance on either side that we're going to see an item number different than this. So what we're going to do is work on the variance. And the variance is going to be taking the 1,000, that's the n, times the p, which is our failure rate, times the q, which is our success rate, which is kind of weird, right? Because you're kind of saying that your success is a failed PS3, and then the success is really our failure here, failure to have a failure, which is weird. And this will give us 47.5, or basically 48 systems. Now what we're going to do is work with the standard deviation, because this is the one we've really kind of hammered in this class, because we're going to take the square root of that 47.5, and the square root of 47.5 is going to be like 6.8, and that's like close to 7 systems, so approximately 7 systems, or 6.8. It might be 6.9. I'm going to bring up the calculator in just a second to let you look at that. But this 6.8 really means that 50, give or take 7 systems, is going to be the normal, you know, within one standard deviation, you know, what Best Buy should expect. So expect 57 on a bad month, and, you know, less, you know, 43 or less on a good month, but normally between 43 and 57. Let me just drag the calculator up to show you those on the big screen here. And I will highlight that the original worksheet has this as a mistake of 4.75. It really should be 47.5. And I said 6.8, but it really, rounding correctly, should be 6.9. But technically 7, right? You know, because we can't have like 6.89 PlayStations. We would have to round up to 7 because we're statisticians. We're going to kind of, you know, err on the side of caution here, if we make error, of course. So thank you for watching. We're going to have 3 more videos after this. And again, thanks again.